Welcome everyone to Managing Changing Data with FME. This is the part 2 in our two-part series. So today we'll be covering flexible approaches to detecting changes. And I am joined by both Dan and Luke. I'll pass things over to Dan to introduce himself.
Yeah, my name's Dan. I've been at SAFE for around 4 years now. So I'm on the customer solutions team. We kind of focus in helping our customers getting the most out of the FME platform. And yeah, I'll pass it off to Luke.
Alrighty, my name is Luke Hicks. I'm part of the technical support team for FME Flow, and I've been with SAFE almost a year now. And yeah, I'm looking forward to sharing some good info with everyone today.
Awesome. And if you are newer to the platform, you can share your reactions with us on the bottom middle. Great, people are already doing that. We also have the polls tab. We do have a couple polls coming up, so keep an eye out there. Any audio or video issues, you can click that help button. And if you do have any questions during the webinar, please drop those in the questions tab. We do have Mark and Evie both joining us on the back end, ready to answer and help us with any questions there. And then we'll also have a little bit of time at the end for live. If you'd like to download the deck, you can do so with that handy download button on the top right of the PDF. All right, at this point, I will ask if our presenters can turn off their webcams just to save on some bandwidth for the remainder here. And I'll pass things over to Dan for our agenda.
Yeah, so we got some interesting topics to talk about today. And then we had part 1 of our change detection webinar not too long ago. And in part 2, we're going to explore some more manual methods. So we're going to go over a few things like modification timestamps, how you can use those in your readers in FME, some format-specific change detection, where we'll be looking at Databricks and how you can use the built-in versioning there. We'll also take a look at database triggers and webhooks for real-time change detection updates. And then we'll also look at how you can use SQL Server's built-in change data capture. And then we'll go over some resources, and then we'll have time for Q&A at the end. All right, so our first poll, which of these methods that I just mentioned have you used for tracking changes? This could be within FME or within other software or platforms that you currently use.
Yeah, and I've launched that poll under the tab there on the bottom right. It looks like we have most votes now already, so that's great. Thanks, everyone.
Yeah, a lot of votes for ChangeDetector, which is great because we're still going to be using that for these other processes, and we're just going to be kind of using it alongside the other methods there that we mentioned. Cool. Yeah, it looks like not many have used these other methods, so looks like it'll be a great webinar and a great chance to learn about some new methods. So
awesome.
Let's get going through the introduction here. So yeah, in part 1, we kind of focused on the change detector transformer and how we can use that to spot differences between our data sets. If you haven't watched that webinar, highly recommend it, but it's not necessarily required for watching this webinar. So you can always go back and watch that afterwards to get some more tips and tricks. But today we're going to be focusing on how we can use other popular change detection methods in FME. So our second poll here is, what's your biggest headache with changing data? Is it detecting changes reliably, having too many manual steps, dealing with versioning and backups, auditing and communicating those changes to stakeholders? Let us know.
Yeah, and I did make that one, so you're welcome to choose your top 1 or 2. Give everyone a few moments there. All right, and most votes are in now.
Yeah, detecting changes reliably. Not surprised. Yeah, can be pretty tricky to make sure you're capturing all those changes, especially if you have downtimes and whatnot. So yeah, too many manual steps as well. That one's the second place one there, and for sure that can be a big part of it. So FME can really help with that. And yeah, that's what we'll be demonstrating today. So why would you want to use these other methods? The change detector transform is a pretty powerful tool, but how can these other methods help us out? Well, handling larger data sets efficiently is one of the main things here. If you have massive data sets and you want to do change detection within FME, you really only want to be reading in your latest records and performing the change detection on those. Things like modification timestamps or using SQL Server's change data capture that's built in can help you just only read in those recent changes. Real-time responsiveness is a big one too. Change detection capture using the change detector and running that in something like a schedule is going to be very batch based, which is not bad. It still works really well. But when we look at database triggers, we'll kind of explore how we can use the webhooks in FME to kind of automate that and have those changes captured in real time. We want to minimize data movement, so this kind of ties into that first one. We want to reduce our API calls, storage and cloud costs and all that. So just kind of make sure that we're keeping things lightweight with these other methods. And yeah, there's a lot of existing methods out there, so why not use FME to tap into those? There's been a lot of effort put into those other methods, so we can kind of leverage those and easily use them in FME. So traditional, change detection methods are still important. A lot of people are still using them. So that's why we're kind of looking into this today, is because we still want to use those methods, and it'll be useful to see how you can use those in FME. So if you're not familiar with our platform, we have two products, FME Form and FME Flow, as well as Flow Hosted, which is essentially a cloud managed instance of FME Flow. FME Form is your authoring environment. This is where you build out your workflows, where you test them out. And FME Flow is where you take those workflows that you created in FME Form, you publish them up to FME Flow, and this is where you can automate them. So you can set up automations, schedules, web apps, and lots more. And in FME, we have unrivaled data support. So we have support for both, tabular data, big data, spatial data is one that a lot of people are using. Things like CAD, database support is pretty huge. And we're always introducing new formats and listening to what our customers want. So if there's ever a format or data type that you're interested in, do let us know. And we'll either be currently considering it or we'll take a look into it. So yeah, just going again over the different change data capture methods, kind of introduce us in our agenda, but we're mainly going to be looking at numbers 2 to 5 there. We kind of covered change detector in part 1 of this webinar. And we also have another webinar on schema drift, if that's something you're also interested in, that kind of ties into change data capture a little bit. We do have a webinar on that, which would be great to check out after this. So kind of comparing these different methods, what's the difference between them at a high level? What is, the benefits of each? So with real-time capability, that's only going to be for the database triggers, since that's going to be triggering a webhook in real time when those changes are made to a table. For all those other methods there, they're going to be batch. So that's going to rely on, say, a workspace that's set to run on a schedule or an automation in FME Flow. In terms of capturing deletes, modification timestamps, so essentially using a where clause, is not going to capture those deletes, but all those other methods are going to capture deletes if that's something that you want to capture. In terms of the effort to set up each of these, the first two there are going to be relatively easy to set up because it's kind of already baked into the product, whereas setting up database triggers and the log-based CDC takes a little bit more work. I'll say that the log-based CDC isn't too complex. It's essentially two SQL queries to essentially enable it on your database, and then off you go. So that one's not too much setup. Same with the database triggers. And then in terms of being format and tool specific, of course, the format specific CDC, pretty self-explanatory. We'll take a look into those and what formats offer a CDC. And then log-based change detection capture is going to be specific to certain databases. And at this point, I'll pass it off to Luke.
Alrighty, thank you, Dan. So the first change detection alternative that I'll be showing you today is through modification timestamps. So how modification timestamps work is that we are using a timestamp filter to retrieve records by the last modified date. So modification timestamps allow us to track when data was changed through comparison of timestamps within multiple data sets. And timestamps can be used to retrieve only the records updated since the last check. If you know when your last check was, then it's quite easy to query just when your last check was instead of going through the entire data set again. And this reduces processing time and data volume during FME processes and FME operations. So with FME supports format-based queries and filter transformers for dynamic filtering. We have built-in tools to simplify date-time conversion and manipulation across different formats. And it's easy to update modification timestamps or status fields during read and write processes. And that ensures that records will remain accurate and traceable. So for tracking dates, this is just an example here. So we can use metadata to use our comparison for change detection. So you can use things such as the status, the time and date of the last update, or we can filter by the last editor, for example. And the way that we can filter our data is using generic where clauses. So these are some examples here that you can put into a reader in FME form. So you could do something such as a specific date. So if you know what day you want to read in, you can say specifically September 23rd, 2024, for example. And there's a variety of options here. So you can really filter by any date that you want as long as it's a valid SQL query. So here we have the feature reader, which will perform many queries, which I'll show later in a demo. And then we have an alternative method here, which is by using the where clause when reading in data, and then using a feature merger as our comparison tool to be able to determine what features have been added, deleted, or updated. So before we get into our modification timestamps demo, I'm just going to talk quickly over our goal, our block, our key, and our result. So our goal is to detect and process only the data that has changed using timestamps as the basis of it all. And our block is that the manual comparison of this between data sets is really not feasible in most cases, especially if you have data sets with hundreds of thousands, or millions of features inside of them. And the key here is to use where clauses in FME to filter the records based on timestamp criteria. And this allows you to isolate only the records that need attention without processing the entire data set. And a result will be data that is efficiently filtered and compared. All right, let's get into the demo. Okay, so here we're just going to show the where clauses first. So I have a reader here that reads in addresses. And if I press run here, it'll read all the data in the table. So when it reads out the data finally, we'll get 13,597 features. So if we want to filter it further on a specific clause, we can copy or type in a SQL query and put it in the where clause parameter of your feature reader. So if we run it again, I put in the last update to a very specific day. And because we're only reading in one day, it'll perform the query. And now we only have 36 features run through. And it was also a lot faster than the 13,600 that we had before. So here's another example of doing it between two dates. So let's see how this one goes. Alrighty, and this one was a pretty large range, so now we have 10,841 features read in. And now if we were to do one where if you knew the last time that you updated was February 15th, for example, then we can read in anything between February 15th and the current day to see what has changed. And yeah, here we see 1,132 features read in. Alrighty, so now we're going to our second workflow here. So this workflow here has a CSV file that's being read in, and then also our database that we had in our previous workbench here. So we have these two methods on the bottom that my mouse is over, which is the SQL executor and the feature reader. So the SQL executor and the feature reader themselves are reading in from the table. And because of this, every single time it reads one feature and then performs a query. So as you can see here, it's very slowly counting up. And this is technically a feasible option, but not a very fast one, especially if you have the thousands of features like I do here. So we're going to stop this one. And now we're going to switch over to the alternative method, which is to read in both features and then use a feature merger as our comparison tool to determine our change detection. Alrighty, so we're just going to press run here. So you can see it reads in both the features and it merges them all, tests which data has changed, and then you can see almost instantly it was able to tell you what data has been updated, what data has been added, what data has been deleted. So we can see here that there were 3 pieces of data that were, or 3 features that were updated, and it shows all the information there, such as the address, when it was updated, who updated it, and what the status of the feature is. And yeah, so that is our first option there. To summarize it, why is this method useful? So the first reason is fast and simple change detection. Using timestamp-based filtering dramatically speeds up the process of identifying changes in large data sets. And also targeted data retrieval is very important. So being able to use these where clauses to only filter out and process the data that you're looking for, it helps out a lot. And why use FME for this specifically? The first option is metadata handling, or the first reason is metadata handling. FME offers the flexibility to record, update, manage any metadata fields as part of your workflow. And this makes your solution more dynamic and also more trackable. And the really big benefit of FME is that it's format agnostic. We have over 500 readers, writers, and these comparison tools could be used with any of those as long as they have something to compare upon, such as a timestamp. And all right, I'm going to pass it off to Dan to show off our next demo.
All right, thanks, Luke. Yeah, so we're talking a little bit about format-specific change detection. What do I mean by this? Well, some of FME's formats come with built-in versioning functionality. So something like ArcSDE, so your enterprise geodatabases, those have versions and branch versions, and you can compare between the 2 versions, as well as Small World has support for this, as well as Oracle. So this is kind of the versioning that's built into our readers. But there are other formats out there that support versioning that you can access using SQL queries. So we have a few articles about these topics, about ArcSDE and the other ones. So I thought it'd be cool to kind of touch on a different format for this webinar, but we'll share those resources out at the end if you are interested in versioning for something like an enterprise geodatabase. So some of those other platforms with support for versioning. Not all of these are formats within FME. The first one there is Databricks, Apache Iceberg, and Apache, I might be saying the name wrong, but Huddy. Those both have support for tracking changes and storing history. So the advantage here is that you're going to be able to rely on the platform itself to be storing those changes and that version history instead of having to track it yourself. So with these other formats with support for versioning, we can use SQL queries to access the history of the tables, and then we can read in the specific versions. So this removes the need for staging tables and allows us to easily automate these workflows with FME flow schedules or automations. Again, the purpose of this method is really to take the heavy lifting off of FME and leverage what's available with the platform that we're using. So let's rewind a little bit. With Databricks, you can time travel. Databricks stores table history, enabling accurate change tracking. So each operation that modifies a Delta Lake table creates a new table version. We can time travel using a specific version number. So essentially each time a change is made, you get a new version number, or we can travel to a specific date and time. And time traveling with Databricks is pretty simple. When you're doing your select statement on your table, you can specify the version number at the bottom there, as well as the timestamp. So either these methods work, and within the Databricks interface itself, you can see the different versions available and when those changes were made. So an example use case and how FME can be used for this. Well, we can use FME to create the table history to get a list of those versions, all the different versions available to us. We can then query the current version and I guess the next version available, or what we could consider the previous version. And then we can use the ChangeDetector to extract the differences between those two versions and synchronize those changes to an external database or audit that data or create reports. So this is that workflow at kind of a high level. We'll go through this workspace in a demo in a second, but you can see here it's a pretty simple process. We're essentially just extracting the table history, reading in the latest versions, and then extracting the differences and making those changes in our SQL Server database. So our goal here is to track and synchronize changes from a Databricks Delta Lake table. The block is that manually tracking and comparing these table versions is complex. We don't want to read in all the data. We just want to read in the latest changes. So we can utilize Databricks time traveling functionality and extract the differences using FME. This results in efficient change tracking using, again, the built-in functionality that's available with the formats and the platform that we're using. So we'll take a look at our demo. So you can see here in Databricks, this is our table. This is the history tab where you can see all the different versions available and the different operations that were performed. So this is kind of your overview of your table history. And let's go into our workspace. So the first step here is going to be our SQL executor. In here, we can use our describe history SQL statement. So what this is going to do, it's going to return the exact same information that we just saw in Databricks. It's going to tell us the different versions available, as well as when those changes were made and the operation. So we'll run that. We'll give it a second. And you can see we get 8 records back. So each record's representing a version within Databricks. So what we really want to work with here is those top 2 versions. We just want to read in version 7 and version 6 and then compare those changes. But another thing to keep in mind here is the operations. Databricks is sometimes performing optimized operations. So we need to filter those out first before we can actually kind of create our current and our previous versions. So we're using a tester here just to filter out for those copy into and those merge operations. And you can see we realistically have 5 different versions that we can work with. And we have those merge and those copy into operations. So in the attribute creator here, we're using this to create the previous version attribute. So this uses adjacent feature attributes. Essentially what we're doing here is we're taking the value from the next row or the next record and inserting it into a new attribute on our first row that's called previous version. This will make a little bit more sense when we run this. So we'll just give it a run. And you can see our previous version is 5 and our current version is 7. So now we've kind of taken that record, the value from the record below, and we've pulled that up to our top row there. And the reason we're doing this is because we're going to filter out for just the most current row, which contains our previous version and our current version. And then we can use those 2 values in 2 separate SQL executors. So this is a simple select all statement, and we're doing the version as of. So this one is reading the version attribute, which is our current version. And then this SQL executor is going to be doing the same, but reading in our previous version. So we'll cancel out of this, and then we'll take a look at our change detector and then run everything. So in here, we're doing our matching on our key attributes. You're probably familiar with the change detector. You might have used it before, you might have not, but it's pretty straightforward. You just set up the attributes that you want to check for updates on and changes on, and then you make sure you have a key attribute for performing that row matching. So we're going to read in all our records from Databricks, and you can see with our different versions there, we're going to be getting a different number of records back. And when we run that through the change detector, we're going to be getting some updates as well as some inserts. So we can connect that up to our feature writer, which is synchronizing those changes to our SQL Server database. We have our feature operation set to FME DB operation. So what this means is that depending on the port that is coming from the change detector, it's going to perform an update, an insert, or a delete for us. So it just simplifies our workspace. We only have to have a single feature writer, and you can see there all our 100 features were either written or updated in our SQL Server database. So you could use this method for synchronizing between different platforms. And yeah, really the main point here that we want to drive home is that there's a lot of tools available that you can leverage within FME. In this case, we're using Databricks' time travel, but there could be other platforms out there with similar methods. The SQL executor makes it easy to compare the historical and the current versions. And then we could take this workspace, publish it up to FME Flow, and set it to run in a schedule, set it to run once a day or every hour, even if we wanted to, and have that constantly updating our data, capturing those changes that are made in Databricks and synchronizing them elsewhere. All right, and I'll pass it off to Luke again to talk about database and webhook triggers.
Awesome. Thank you, Dan. So yeah, we're going to be talking about database and webhook triggers as options to or alternatives to change detection. So first, we're going to talk about database triggers and how they work. So database triggers can be used to automate change data capture by logging data changes into shadow tables in real time. These shadow tables are a reflection of the main table, and it is used exclusively for tracking the inserts or the updates or the deletes of the main table. So as you can see in the image here, there's a few things like inserts, there's 5 inserts, there's 5 updates, there's information of the new value, the old value. That's all from the shadow table here. So This method can provide a reliable and efficient way to track changes without manual comparisons and can support use cases like auditing, synchronization, and workflows in FME while maintaining your data integrity. So you would set up this, or sorry, I'll show how to set it up in the demo. Before that, I'm just going to talk about the goal block key result, just like before. So the goal here is to track your database changes, but the issue is that it's time consuming and intensive to manually keep track of every table change in a new table. The key is to use database triggers to write a history of changes in our shadow table. And the result is that the trigger will automatically track and populate the changes to the shadow table. So yeah, let's get into the second demo. All right, so we're starting off in our database. I'm using dbeaver to view our database. So we have our public trees CD. That is our main table that we will be writing to. And then we have this trigger connected to it. So this trigger will activate on an insert, a delete, or an update, and it will execute a function called log changes. Now this log changes is a function that will track the data and put it into the shadow table. So it can insert the data and its values or attributes into this new table. Our shadow table is called CD history for this example. So you can see here the insert, update, and delete options are all put into a SQL query. So now if we go into FME Workbench, we can run it here, and I'm just populating the public trees CD table with some data right now. So we added five features here. Press refresh, and we can see here that the 5 have been added. And if we go into our history table, we can see the trigger has been activated, and it has tracked the 5 inserts here. So now if we go back into our workflow, I'm going to switch over from insert option over to the update option. So now I'm going to update the data. I'm just changing one of the fields with some arbitrary information. But if we run it here, and now we go back into our database viewer, back into public trees, we can see that the data has changed. Now the common name is FME lizard. That is not actually a tree, don't worry. But if we go into our history, we can see not only the inserts are still there, but now we have information on the updates. And it also keeps track of the old value and the new value that has been updated to. All right, so now we're going to delete the data. So I'm just enabling the deletion transformers here. Run it through. Back into our main table, quick refresh, and it's empty as expected. Now we go into our history, and it has tracked all those deletions. So the old value is there, the new value is null because there's nothing there anymore, and all that information is kept there. So it's a great way to be able to show what has been done to a table. And yeah. Now I'm going to talk a little bit about webhook triggers. So this can be an alternative option or a supplementary option on top of a database trigger. So a webhook trigger it's set up pretty much the same way that you would into the database trigger. So it'd be through creating a function and then calling that function with the trigger in the database. It's just that this function is calling a webhook in FME Flow. And this webhook is part of an automation that you can create in FME Flow. So when this webhook's triggered, it can send off message in a JSON format to something such as a logger. So you can log your information from a triggered table change, or you could run it into another workspace, for example. You could also send it off to an external action if you like, and be able to notify people on the results or if something's changed and what has changed. And we have a great series of guides on how to set this up. It'll be linked in the slides that you can download further on in this presentation. And this one here shows single edits in Postgres, but we also have articles for bulk edits, and we have articles for a different database. I don't know which one specifically, but we have a lot of articles and a lot of guides on how to set this up yourself. So to summarize the database and webhook triggers, so database triggers can be configured to respond only to specific operations such as deletes or updates only, which would make it possible to track only the changes that matter to you. And when a targeted change occurs, the trigger logs the relevant data into a shadow table for further processing or auditing. And this approach helps reduce data noise and processing overhead by ignoring the irrelevant changes. Webhook triggers in FME flows can be triggered to send that information along into an automation, allowing for immediate downstream processing. And these webhooks can route data to other workspaces, for example, or external systems such as APIs, different notification systems, any of the external actions in an automation you can send that information to. And this makes it easy to build end-to-end workflows that respond dynamically to data changes. And yeah, these triggers are also fully customizable. So you get to decide which operations to track, what data to capture, and where you like to send it. And this ensures that your system remains responsive, not cluttered, and it really focuses on what's important to your specific use case. Now, the only drawback to this one is the setup and the elevated database access required. Some DB admins or organizations may not want you creating triggers or functions, but if they do allow you to create them, then this is an extremely powerful tool to use to detect changes and keep track of them. And with that, I'm going to pass it off to Dan for our final alternative method today.
Great, thanks, Luke. Yeah, so we'll be taking a look through our log-based change data capture workflow. So how does this work? Well, transactional databases store all changes in a transaction log in a database such as SQL Server, which is what we're going to be using in this example. We can enable change data capture using a couple of SQL queries. So first you enable the change data capture on the table, or sorry, on the database, and then you can enable it on the table. It's pretty straightforward. I wouldn't say I'm much of a SQL person myself, and I was able to set it up relatively easily. So hopefully that gives you some context. Each of those transactions are recorded with a log sequence number, so an LSN, in the change data capture table. So we can take a view of that table, grab the latest LSN, and then just only read in the records that were changed in the last transaction. So the goal here is to capture and process changes from a SQL Server database. We want to synchronize these up to another platform, such as ArcGIS Online. Traditional methods are resource intensive. With traditional methods, we'd have to read in the whole table in SQL Server. And this could be hundreds of thousands or even millions of rows that we're having to read in and then compare against each other. Whereas when we're using SQL Server's built-in CDC functionality and FME, we can just read in those records that were recently changed. So that could be inserts, updates, or deletes. We're able to detect all of those. And the result is going to be real-time updates to ArcGIS Online, and we're only sending that change data through our workspace. So again, we're keeping things lightweight. We're making it easier both on FME and the database, and just reading in the data that we need, which also increases our performance. So let's take a look through our demo. So in our first workspace here, we're reading data from the City of Toronto's Open Data Portal API. So this includes information such as the status of road closures, And after we process that data and create our geometry using the vertex creator, we're then going to be using the change detector to look for those changes between our existing data set in SQL Server and the new data that's coming from the API. So this is a pretty familiar process. This is going to be using a change detector. This is our road closures data set. You can see we're also checking geometry in our change detector. I know this is a question that came up. So in the change detector, we can check for geometry, and we'll expand that. And we set it to match for 2D geometry. We've set up lenient geometry matching, and that just allows us to more easily match between a geometry. Sometimes you'll have an API that has a certain level of precision, and your database might have its own level of precision as well. So that makes it easier for the matching. So we're using our SQL creator here to query for the most recent LSN. Essentially, this LSN is kind of a key for the latest transaction that was made in our SQL Server database. With this LSN, we can then use this in a where clause to only query for the last changes that were made. So you can see down here in our visual preview, we have our last LSN. And then if we open up our feature reader, this is for our SQL Server table. And that is the name of the CDC table underneath. We're then using our LSN to query for only the features that match that latest LSN. So you can see here we get 420 records coming out of the feature reader. You get additional fields there, such as your LSN numbers, which you can then filter out, but you also get all the other information here. We also get our operation, which is coded by a number. We'll change this later using an attribute value mapper. Each of those numbers represents an insert, an update, and a delete. So that's what we're doing here with our attribute value mapper. And then in our attribute creator, we're just adding in a date modified field. So in the test filter, we're splitting out our data into our different operations that were performed. So we have our deletes, inserts, and updates. Those inserts, or sorry, those deletes will be joined up to our existing data sets. We can also send our delete information to a separate table where we might want to track the historical road closures. So since those are being deleted, they are no longer relevant. So we're storing them in a separate table. In this step here, we're just reading in our existing data set from ArcGIS Online and joining this data up to our updates. The purpose of this is we need object IDs to perform those updates in ArcGIS Online. So we're just fetching those and joining those to our existing rows, since those are the updates. And then the last step there is writing our data to ArcGIS Online. So this is those updates and those inserts. Again, it's really up to us how we want to set up the workflow. We get the control over our workspace of where those records are going. So we could still include those deleted records or make those changes into our ArcGIS Online table. But in this case, we want to store those deleted records in a historical table. And that's the end of that demo. So in summary, we're able to read the change log table from SQL Server. We'll also share out these workspaces after the webinar, so you'll have access to the workspaces and you'll be able to easily implement the same workflows in your organization. And then we can apply these changes to a web map hosted in ArcGIS Online. I didn't show that portion just to keep things on time. But yeah, we're just writing those changes out to those records in ArcGIS Online, and we're able to, store those changes in different tables if we want. So why does this method work so well? Well, again, we're leveraging the built-in CDC functionality in SQL Server. This means there's no custom change tracking required. Why would we want to use FME for this process as opposed to just, using SQL Server? FME is a visual process. It makes it easier to kind of get a view of what's happening when you're running your workspaces. It also makes it really easy to synchronize and integrate this data with other platforms that SQL Server might not be able to write data to itself. So yeah, and again, one of the main things here, it's kind of a theme, recurring theme across all of the methods and the demos we've shown today, is that we're only reading in the data that we need. So in conclusion, we kind of give you the choice to control your data and manage the changes. There's lots of different methods here that we've shown today. We have different articles on them, on how to use these methods, but we're really leaving it up to you on how you want to perform this change detection, so you have a lot of control over what's happening in your workspace. So we have a bunch of different resources here that we'll also share out after the webinar. Again, check out that part 1 of managing changing data with FME. We have our change detection article series. We have our article on extracting differences from an ARC SDE geodatabase. We have that article on using the webhooks with database triggers, which is really useful, as well as some other resources there.
All right, yeah, and I can take over here, Dan, if that works.
Yep.
Perfect. Yeah, so just before we head into a few minutes of questions, we're all about free resources here at SAFE. I'd encourage you to take a look over at both our knowledge base and our academy. Great places to find our knowledge articles and guided learning at your fingertips. And then our webinar program, we do have some upcoming webinars available over at safe.com/webinars that you can take a look over, including a webinar on Databricks actually coming up here. So keep an eye out for that. You know, that was discussed a little bit in this webinar today, and lots of on-demand webinars as well. So definitely use that search functionality. And in terms of next steps to take, we would love to chat anything data with you. Get in touch with us over at info@safe.com. We'd love to help you get started or address any challenges you might be facing. And our FME Accelerator course is 90 minutes free of charge, and it's a great place to get started learning the basics of FME. If you're just starting out, definitely would encourage you to take a look at that course. Claim your community badge. So if you do redeem these badges in the community, I just dropped the code in the chat there. The community is a great place to network with other users alike, as well as experts, and lots of forum opportunities there. Someone might have just asked the question that you were also wondering and is finding the solution to that. So I'd encourage you to take a look if you aren't a member of the community. Our peak of data and AI is just, I guess, under 2 weeks away now, which is crazy. May 6th to 8th in Seattle. We hope to see you there. And with that, I'll invite the team on the stage and we can take a look over any questions together. It does look like we got to most, if not all, of the handful that have come in so far. But if you do have one top of mind, please do drop that in and we can take a look through and get to as many as we can here.
There was one question from Darren about just feature writers and stuff, but it might be a broader question about feature types. Does anyone have any suggestions around using the change detector and bulk inserts and deletes?
Could you do a group by on the operation? So it's doing it in 3 different sets. I mean, the question was about, because if you do inserts, deletes, and updates, you can't do a bulk insert because you're getting a mix of things. So the only thing I could think of was use a group by, and then all your inserted, all your deletes, all your updates are being run separately, and then maybe you can do bulk. I haven't tried it. That's just a guess. So that's a great question.
Yeah, I guess adding on to that, you could have separate writers or feature writers for each of your different operations.
Yeah,
Kind of
I think
same
the
thing you're
issue
talking
is,
about, Mark.
yeah, I think the issue is with multiple feature writers is that if you are writing to the same database, it'll lock. So I think better yet is to have one feature writer, but multiple feature types, each for the different operations for that one table that you're trying to get to, or different tables or whatever.
And if you do multiple feature writers, are they one after the other, or are they running in parallel? Because I can see running in parallel might lock things up.
Yeah.
And one after the other, maybe that would solve that problem.
Yeah, if you're running in parallel, it'll definitely lock for sure.
You would think, yeah. So that might be another way around it, to run them in a series, one after the other. The other question was about Databricks. And I mean, I've never used this format before, so I'm not certain about this. But Dan, you said that Databricks doesn't support a geometry type, so it's just plain text. Is that non-spatial?
Yeah, I'm imagining from Emma's question, if they have geometry in their Databricks, it's probably like stored as GeoJSON or well-known text. So you just have to use a geometry replacer to essentially create the geometry in FME, and then you can use the ChangeDetector to detect changes on the geometry itself. You can also detect, do the change detection on the GeoJSON or well-known text itself. It'd be kind of the same process. Underneath I don't know if that's exactly what the change detector is doing with geometry, but I think that does come into play. So yeah, but yeah, we didn't show it off too much, but there is a check geometry parameter. If you're working with just 2D data, we recommend changing it to only matching on 2D data, because it can get a little funky with the default value, which is set to full. And yeah, there's options for lenient matching as well, which can be useful if there's different levels of precision between your data sets.
Yeah, that was one thing I was going to mention, because you'd mentioned lenient matching before. And I know one of the things it lets you get away with is if your polygon is anti-clockwise instead of clockwise, lenient will say, well, that doesn't matter. But if it's not lenient, then that does matter. So I don't know if there's any other specific situations you can think of, but that's the sort of thing that lenient geometry matching lets you get away with, shall we say.
Yeah, the main thing I can think about is if you have data coming from two different sources. So say you have, SQL Server, and then you have maybe ArcGIS Online. Underneath, there might be a different level of precision to the geometry. So you might have, just even the decimal places this is getting very technical, but yeah, if there's a mismatch, even the smallest bit with the geometry, it's going to say that there's, new records that exist, which might not actually be true. It could just be a small bit of precision difference there. So yeah, something to keep in mind with the geometry and the change detector.
Yeah, that's a good one. I'd never thought about that. So yeah.
Yeah.
New question from Lewis. Yeah, around MS Query.
So it sounds like running MS Query for dates is a lot faster than looking for a unique ID. Yeah, I would think so, because you're reading it in bulk, and you can kind of do, I guess it depends on what your SQL query is. It's kind of very situational, but I would say that using dates is probably going to be faster, because you can also, check for dates that are greater than certain values and all the different operations that Luke showed in his demo.
Yeah, I think you'd need to know the unique ID you were looking for or whatever. So if you wanted to know the records for the last week, then you'd need to know what the ID number was prior to the last week. Whereas with the date, it's just different ways, I think, of doing it. I don't know that one is faster than the other. It doesn't.
Yeah, it's worth testing it out yourself in the workspace as well. If you think it could be faster, if you think if you just want to compare different methods, it's worth checking it out.
Yeah.
Yeah. Awesome. All right. Well, I know we are at the top of the hour here. Maybe just final call it to the team in case there's another question I'm missing, but it looks like we've gotten to them all at this point. Okay.
Yeah.
Perfect. Well, just a huge thank you to our whole audience for joining us today. We really appreciate your time, and we hope you enjoyed this webinar series and got a lot of value from it, as well as Big thank you to our presenters for all their time in preparing today's content. Shout out to Luke. I believe this was his first webinar, so great job, Luke. Thanks for all your time and work on it, especially.
Thank you. Thank you.
Yeah. If you do have a brief moment to fill out our webinar survey, we appreciate any feedback, as always, helps us improve our program. And we hope that you all have a great rest of your day. Thanks, everyone. Bye for now.
Thanks, everyone. Bye.
Thank you.
Thanks.
Bye.